Good morning, everyone. Myself, Laveena Sheghal, Assistant Professor, IT Department, IIMT College of Engineering. Today, I am here going to discuss about linked list in data structures. So, before starting this topic, I want to tell you about what is data structure. First, we should know before starting this what is data structure. Before starting data structure, we should know what is data. Anything which gives us information about anything is called your data. For example, we have a student roll number, student name, student department, student branch, roll number, address, whatsoever. It's called your data. And what is structure? How we are going to manage our data and represent our data is called your structure. Means representation of any data is called your data structure. How we are going to manage our data in a tabular form, in a graphical form, arrays, linked lists, tags, etc., graphs, trees, so many forms are there in we can store our data or represent our data in an organized manner. So now comes to the data structure. Data structure is a combination of data plus structure is equals to your data structure. It is a way of organizing and storing your data in a particular manner so that we can use it in an efficient, better way. Is called your data structure. It tells us basically about what data items are stored in which form. Tabular, graphical, trees, tags, queues, linked list, and what are the relationship between those data items. For example, if I say that student roll number is 01 and name is Kamal, so Kamal representing the name have a roll number 01 belongs to a branch IT or CSE or AI. So all the fields of that tuple are related to each other. Means our data structure is showing that our data is saved in a tabular form which shows a relationship among data items, attributes of the tuple. Okay, so data structure is further divided into two parts. One is your primitive data structure and another is your non-primitive data structure. Primitive data structure is those data structure which are designed by machine, which is inbuilt your machine. We don't have to create any kind of structure of that. For example, float, character, integer means your computer, your machine is accepting only integer values in integer, character values in character, and float values in float. Non-primitive data structure is those data structure. Non-primitive data structure is those data structure which is a collection of primitive data structure which is built from or designed from the combination of multiple primitive data structure. And non-primitive data structure is further divided into two parts, that is linear data structure and non-linear data structure. In linear data structure, we are organizing our data in a sequential form, one by one by one, which includes your stacks, which includes your queues, arrays, and linked lists. And non-primitive data structure is the way we store our data in any form, in any another way. Like graphical trees, we can store one book there in a library. If we are store in all the books in a organized manner, that is called your stack. Either we are storing in stack or either we are storing queries. So this is the form of data structure. So if I talk about your linear data structure, first comes arrays. So arrays is also a linear data structure, but array has the one drawback. We can't add uh, any data item if we have the size. Suppose I give you one example. If I had an array of size 5, means we can store only 5 items in that array. Okay, if I want to store that 6 element but arrays of 5 size, for example 1, 2, 4, and 5 and 6, 5 items are there. If I want to store third item after the second, but we don't have the size, We have to increase first. We have to increase that size, means 5 to 6, array size 5 to 6. After that we have to step for 6, then 5, then 4, and that we can insert the item of array in the that place. We have to vacate that place, right? So if this is the major drawback of array, which is overcome by your linked list, means it is also a linear. Yes, uh, this drawback has been. Yes, this drawback has been overcome by your linked list, which is also a linear data structure. So in this linked list, we will going to discuss about what is linked list, what are abstract type of data structure, basic operations of linked list, insert, find, delete, and print, variations of linked, that is types of linked list we are going to discuss in this session. So first is linked list. Linked list is also a linear data structure. We store our data in the form of sequential, which is the overcome of drawback of average. So, so this is the linked list. It is basically a series of connected nodes. It is represented by a node which contains two parts, means two boxes. One is telling your data, which is your value, and this is the pointer or address you are pointing to another. It comes under the form of a chain, like you have a ringer chain of a long list. It is called that linked list, right? A linked list is a series of connected nodes. Each node contains at least a piece of data, any type you can take, pointer to the next node in the list. For example, this is the node A. A is telling you about your input or information, and this is the pointer. We are pointing to another address, that is B. This tell here with information is about your address. Here is the value of input we are giving to connect the another way. Correct. Now, head is the starting pointer of the first node, which is always point to null value. A simple linked list class, we have two classes, node and list. Declare node class for the nodes. Data, double type data in this example. Next is the pointing address to the next node in the linked list. For example, we have created here a public class by name node, in which we are taking this data items and pointing node star to the next pointer, right? So, a simple linked list class can be declared list which contains a head pointer to the first node in the list, since the list is empty initially, which is set to be as null. So, operations on list. First, we can take a class, the labeling list. It is a public class. Starting is null value. We have taken it void as a constructor like Boolean application. This is the program how we can declare the list class containing constructors and operations of list. You can check it out examples. Now, operations of linked list. A simple linked list class and its operations is empty. Empty determines whether or not the list is empty. Insert node. when we want to insert a particular items. For example, I have said 1, 2, 4, 5, 6 in an array. If I have to insert the item third in the linked list, so I have to create a node. I have to create one node which shows a value of 3 and another pointer addresses to the connecting which connects to the address to the 4 and previous starting address to the 2. So it is a formula how we can insert the node at a particular position. How we can find a node with a given value. If we have an address of a value, so we can easily to find a value. How we can delete a node with a given value and print all the nodes in the list. So first comes about inserting a new node. If when inserting a new node, you have to check whether your linked list is overflow or not. If it is overflow, you can't insert any value. If there is a vacant space, you can insert a value. So node insert node in index double x. Insert a node with data equal to x after the index the items. When index is 0, insert the node as the first element. When index is 1, insert after that and so on. It means that initially we have start with null value. After that we have to 0th position, 1 position, 2nd position and 3rd position. If you have a value where you have to store insert that node, you can insert at that position. If you don't have a value, you can insert at the last position. If the insertion is successful, return the insert node, otherwise returns to the null value. So these are the steps how we can insert a new node in the linked list. Locate index item element. Allocate memory for the new node means allocate the address where you want to store in a memory. Point the new node to the its successor means uh, here we can say we are pointing the node to the another node. We are creating a linked list. This is showing the information and value, and this is the pointer and addressing where we are connecting to the another one. Example, for point the new node to its successor, point the new node predecessor to the new node. If I want to insert this node, if I want to insert here a node, first I have to connect this address to here and this point to the another. We can't insert directly. So this is the way we can insert the new node. In inserting a new node, there are four possible cases where we can insert a node. Insert into an empty list means we can insert in front, back and middle. We can insert a node in the after the starting point. We can insert in the front, we can insert in the back, in the middle, means starting, in the beginning, in the end, or in the middle specific position where you want to insert. But in fact, only need to handle two cases. Insert as a node, first node case 1 and case 2. Insert in the middle or at the end of the list case 3 and case 4. So these are the examples of how I'm showing to locate index the node if there doesn't return run value. You can check it out here. In the create a new node. So this is the formula of creating your new node. Insert as first element. Insert after node. Now, how we can find a node? If a linked list is there, if I want to search an a particular node, how we can find out a new node? Initially find out you can take a variable double x, search for a node with the value of x in the list. If such a node is found, return its position, otherwise return 0. Means if you have a given a value and address where you can find out, is a way you should know. For finding a node, you should know about the address of that node and value or information about that node, which I've already tell you in the linked list. Means there it is divided into two parts. One is pointer and one is your pointer address, and one is your input and value information. So this is the example how we can find a node. Here you can check it. Otherwise it return 0. If you find out, it will return here a value. If you don't find, it will return 0. Now, deleting a node. How you can delete a node from a particular list? You can check here underflow list. And earlier inserting time we are checking the overflow. Here we are checking the underflow. Delete a node with a value equal to x from the list if such a node is found, returning to its position, otherwise return 0. Though here are the desirable steps which we have to follow for deleting a node. Find the desirable node. Similar to find a node, which node you want to delete from a chain of a linked list. Realize the memory occupied by the founder. When you find a node vacant which you want to delete, vacant at memory means you are removing a particular book from your library, for an example. So similarly, you have to occupy that first memory and then vacant that memory for when you found out. Set the pointer to the predecessor of the found node to the successor to the found node. So, like insert node, there are two special cases. Delete first node, delete the node in middle at the end of the list. Means you can delete the node from the beginning, either from the end of the list or in the middle. There are three cases you can find out, special cases. So there is, for example, here are we can how we can delete a node. You can check it, try to find the node with its value which is equals to x. Means x is the previous value or predecessor which you want to delete from the linked list. Deleting a node, how? So we want to delete this particular node. So first I will check the address and then its value at here. How you can, this is an example, you can initially initialize with your class, your deleting node while this in while condition, this one. So if this node previous node is equal greater than equals to next equals to this one, deleted node, otherwise you can left out. So this is an example how we can delete a particular node from the linked list. And now comes to the how we can print all the items, all the data items in the elements of the list. So this is the class we have, you can take it, print the data, all the items, print the number of the nodes in the list. You can check while the number of nodes in the list which you want to print out. Okay, destroying the, how you can destroying the list using the destructor to release the memory used by the list. So these are steps to the delete each node one by one. These are the few examples which is you can find out here which one is successful and unsuccessful. So there are variations of linked list. Variations means types of linked list. Circular linked list. The last, when we are connecting our last node with the first node, it means we are making a circle starting with the ending. So last means last pointer address pointing to the first one value. So it is a circular list. Last node points to the first node of the list. How do we know? We have finishing traversing the list. First, we are traversing means when we are moving from one node to another node to another node means we are visiting each and every node. And after the here, we are connecting this node to here. to then it is called your circular, means we are making a circular chain of that list. Doubly linked list means when each node points to not only the successor but the predecessor, means you have the two addresses. In double linked list means here you can see here B is the value, it is the address pointing to the next node, but it is the address pointing to the its predecessor, means previous node from where it is coming and from where it is going, connecting. So this is when you have two addresses with one value, that is called your doubly linked list. Each node points to not only the successor but the predecessor. There are two null values at the first and the last node in the list. Advantage of this node is that in given node it is easy to visit its predecessor and convenient to traverse it backwards also. From where it is coming and from where it is going, means from how we are connecting from one city to another city, from where we are coming and from where we are going to the destination and arrival point, right? So array versus linked lists are more complex to code and manage than arrays, but they have some distinct advantages also than arrays. Linked lists are more, it is advantage also dynamic. Linked list is dynamic, which can easily grow and shrink in size. We don't know to how many cores will be in the list. They are created in memory as needed. In contrast, the size of a C++ array is fixed at a particular compilation time, means we can't insert the array at the in the array at a compilation time. We have to increase the first of all size of that array and then we can want insert in that, right? Easy and fast insertions and deletions. So insert and delete an element in an array. We need to copy temporary variables to make room for new elements or close the gap caused by deleted elements. With the linked list, we need to move other nodes, only need to reset some pointers. So thanks, Mike. This is the session of a linked list which we have covered in the data structure. It is very important from your examination point of view also. You can discuss any query, any options. You can discuss. Thanks a lot for covering this session in the linked list of the data structure.